Standard 7th, Subject Maths, Chapter 13, Pythagoras Theorem, Practice Set 48. Dear students, let's recall about right angled triangle. We know that a triangle with one right angle is called a right angled triangle, and the side opposite to the right angle is called the hypotenuse. Now you have an activity on page 87 of your textbook. All you have to do is write the name of the hypotenuse of each of the right angle triangles shown below. Let's have a look at the first figure. In triangle ABC, we can see that angle B is 90 degree. So the hypotenuse is just opposite, that is side AC. So we can write the hypotenuse of triangle ABC is AC. In the second figure, you have to first locate the right angle. Yes, angle L is the right angle and the side opposite to it is the hypotenuse. So you can say that the hypotenuse of triangle LMN is MN. Next, in triangle XYZ, we can see that angle Y is 90 degree and the side opposite to 90 degree with angle 90 degree is the hypotenuse. So XZ, we can say that the hypotenuse of triangle XYZ is XZ. So here we got all three answers. You can note it down in your textbook on page number 87. Now, how is a right angle related to Pythagoras theorem? Let's learn. Pythagoras theorem. Pythagoras was a great mathematician of the 6th century BCE. He made important contributions to mathematics. His method of teaching mathematics was very popular. He trained several mathematicians. People of many countries had long known of a certain principle related to the right angled triangle. It is also given in the book called Shulva Sutra of ancient India. As Pythagoras was the first to prove the theorem, it is named after him. This theorem of Pythagoras states that in a right angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So, these words, if we put into formula, how will it look? Let's learn. In this figure, you can see a right angle triangle ABC. So, as per Pythagoras theorem, the square of hypotenuse, which is the hypotenuse here, side AC. That means AC square is equal to sum means addition of squares of the other two sides, that is AB square plus BC square. So, with reference to the figure alongside, the theorem of Pythagoras can be written as follows. In triangle ABC, if angle B is a right angle, then angle AC, then length AC square, which is the hypotenuse square, is equal to length AB square plus length BC square. Generally, in a right angle triangle, one of the sides forming the right angle is taken as the base. So here you can see BC as the base and the other as the height. So if we substitute AB and BC as base and height, how we can write the formula? It can be written like this. Then the theorem can be stated as hypotenuse square is equal to base square plus height square. You can see here AC square means hypotenuse square is equal to AB square plus BC square means base square plus height square. Okay, so this is a very important formula. This is the theorem of Pythagoras, which you're going to write down in your notebook before you start with practice set 48. So let's begin. Question number 1. In the figures below, find the value of x. So here you can see one side is missing and all are right angle triangles. If they are right angle triangles, we can use the theorem of Pythagoras to find the missing side. So let's start with the first sub question. We have triangle LMN where angle M is 90 degree. That means the opposite side, that is side LN, is a hypotenuse. So we can write the solution. In triangle LMN, angle M is equal to 90 degree. Hence, side LN is the hypotenuse. We have to write down what we know. That in triangle LMN, angle M is 90 degree. Hence, side LN is the hypotenuse. Now we take it as according to Pythagoras theorem. You have to mention it. According to Pythagoras theorem, write the formula. Hypotenuse square. What is a hypotenuse here? Hypotenuse is ln. So you will write ln square is equal to lm square plus mn square. Length of lm square plus length of mn square. The other two sides are added up with their squares. Now we will substitute the values. ln. What is ln in the figure? You can see ln stands for x, the hypotenuse. So we write x square is equal to lm is 7. So we write 7 square plus mn is 24. So we write 24 square. Now we will solve it. 7 square means 7 into 7 and 24 square means 24 into 24. So we write x square is equal to 49 plus 576. X square is equal to 625. You have to do the rough work. Final answer. Now x square is equal to 625 is the square of 25. So we substitute 625 as 25 square. Now we can remove the squares on both the sides and write x is equal to 25 units. So this way, using Pythagoras theorem, we have found out the side of the right angle triangle which we had to find out. Second sub question. You can see in this figure triangle PQR, angle Q is a right angle. So in triangle PQR, angle Q is equal to 90 degree. First statement. Hence, now the hypotenuse we have to see. Hence, side PR is the hypotenuse. Now we will take the statement according to Pythagoras theorem. PR square is equal to, let's write it down. Length PR square is equal to length QR square plus length PQ square. Now we will substitute these values. We know PR here. So we will write 41 square. Instead of PR, we have substituted its value. 41 square is equal to, how much is QR? X. So x square plus, how much is PQ? 9. So 9 square. Once you get this 41 square is equal to x square plus 9 square, we want to find the x. So we will solve further. 41 square, 41 into 41, you get 1681 is equal to x square plus 9 square is 81. Now we want to find x square, so we will subtract 81 on the other side. So you will get x square is equal to 1681 minus 81. Plus 81 becomes minus 81 when it goes to the other side. 1681 minus 81 gives you 1600. X square is 1600. So x square is equal to 1600 is the square of 40. So you write 40 square. Now eliminate the squares, you get x is equal to 40. The value of x is 40. So in this simple steps, we can solve and find out the other side which is missing of a right angle triangle. Third sub question. In triangle EDF, angle D is equal to 90 degree. We can see angle D is marked a right angle, so it is 90 degree. Hence, now the hypotenuse. Side EF is the hypotenuse. Now, according to Pythagoras theorem, this statement is very important. We write length EF square, that is hypotenuse square, is equal to length ED square plus length DF square. You can take any one side first here to add, because it is addition, doesn't matter. So you can take length DF square plus length ED square, or length ED square plus length DF square. Now substitute the values. Let's check here. EF is given as 17. So we write 17 square is equal to ED is given as x. So x square. DF is 8. So plus 8 square. That means 17 into 17 we get 289 is equal to x square plus 8 into 8 is 64. So x square will be 289 minus 64. 64 we shifted to the other side. That means x square is equal to, after subtracting 64 we get 225. We write it as in this form. We shift the sides. X square is equal to 225. 225 is the square of 15. So we write x square is equal to 15 square. Eliminating the squares, we can write x is equal to 15 units. So this way we have found out the value of x in the third sub question. Fourth, now we have question number 2. In the right angle triangle, triangle PQR, angle P is given as 90 degree. In the right angle triangle PQR, angle P is equal to 90 degree. If length PQ is equal to 24 centimeter and length PR is equal to 10 centimeter, find the length of sec QR. Now we need to draw a rough figure and find out which is the hypotenuse, and then we can use the Pythagoras theorem to find the length of sec QR. So let's see the figure here. In this figure you can see that if we draw a triangle with angle P is given as 90 degrees. So we take the right angle here P, 90 degree, and the other points we name as Q and R respectively. So we come to know from this that it's given here PQ is equal to 24 centimeter. So we can write PQ as 24 centimeter and length PR is equal to 10 centimeter. So we write PR is equal to 10 centimeter in this figure. Now we can see that the hypotenuse, which is opposite to angle P, is RQ, or say QR. Means we have to find the hypotenuse here. So let's use the Pythagoras theorem. In triangle PQR, angle P is equal to 90 degree. We have to first write the name of the triangle and which is the 90 degree angle. Then we have to write the hypotenuse. Hence, side QR is the hypotenuse. And according to Pythagoras theorem, same like before we write the statement, according to Pythagoras theorem, length QR square is equal to length PR square plus length PQ square. So now that we have written a statement, let's substitute the values. QR we have to find out. So we write further length QR square is equal to PR value is 10, PQ value is 24. So 10 square plus 24 square is equal to 100 plus 576 is equal to 676. 676 is the square of 26. So QR square is equal to 26 square. Hence we can say that length QR is equal to 26 centimeter, taking the square root. Therefore, the length of sec QR is 26 centimeter. Question number 3. In the right angle triangle LMN, angle M is equal to 90 degree. If length LM is equal to 12 centimeter and length LN is equal to 20 centimeter, find the length of seg MN. So let's draw a triangle LMN where M is 90 degree. We can see here M is 90 degree, and because of that we have named the other side, other vertex as L and N respectively of the triangle. Now we can say here that we can see that LM is 12. So write LM 12 and LN is 20. ln is also the hypotenuse. That means we have to find mn here. Let's write in triangle LMN, angle M is equal to 90 degree. Hence, side ln is the hypotenuse. According to Pythagoras theorem, ln square is equal to length lm square plus length mn square. Substituting the values, we get 20 square is equal to 12 square plus length mn square. Now length mn square we don't know, so we write it as equal to 20 square. 12 square gets subtracted on the other side. So 20 square minus 12 square is 400 minus 144 is equal to 256. We know that 256 is the square of 16. 16 square is 256. So length mn square is equal to 16 square. Taking the square root, we can find out that length mn is equal to 16 centimeter. Therefore, the length of seg mn is equal to 16 centimeter. Question number 4, the last question. The top of a ladder of length 15 meter reaches a window 9 meter above the ground. What is the distance between the base of the wall and that of the ladder? For this, we will have to frame a figure. Let's have a look at the solution. The top of a ladder of length 15 meter reaches a window 9 meter above the ground. So what we have done, we have taken this window as point A, which is above the ground 9 meter. So this becomes a wall. And the ladder reaches at a 50, which is 15 meter in length, reaches the window which is at 9 meters. So A is the point where we have the window, and this is a 15 meter ladder which is reaching the window from the ground, which has a wall of 9 meter. Because the window is told in the question is 9 meter above the ground. That means there is a wall and this window is 9 meters away from the ground. So we got a wall which is 9 meter and the window on top. Then ladder is 15 meter. What is the distance between the base of the wall, which is B is the base of the wall, and that of the ladder? Base of the ladder is point C. That means we have to find BC here. We know AB, we know AC. Using Pythagoras theorem, since angle B is a right angle now. Okay, because the wall will be built straight on the ground. So it forms a right angle. So let's use Pythagoras theorem to find the distance between the base of the wall and that of the ladder. Solution. The wall and the ground are perpendicular to each other. You can see that the wall and the ground are perpendicular. Hence, the ladder leaning against the wall forms a right angled triangle. So, this ladder forms a right angled triangle. In triangle ABC, we can see angle B is 90 degree. So, according to Pythagoras theorem, AC square, AC is opposite the right angle. Length AC square is equal to length AB square plus length BC square. Substitute the values. AC is 15. So 15 square is equal to length BC square plus AB is 9. 9 square. So length BC square we keep as it is. We write 15 square as 225 and 9 square as 81. Now subtract 81 on the other side to leave length BC square alone one side. 225 minus 81, 144 is equal to length BC square. 144 is the square of 12. 12 square is 144. So we can write that length BC is equal to 12. Therefore, the distance between the base of the wall and that of the ladder is 12 meter here. This way we have completed our practice set 48. Do practice the sums well and do memorize the formula for Pythagoras theorem, that hypotenuse square is equal to base square plus height square. So, dear children, stay safe. keep learning, and thank you.